Hey everybody, this is Christian, and today we're diving into Linux containers, or shortly called LXC, on Proxmox. I know Docker has dominated the container conversation here on my channel for a long time, but LXC is a powerful alternative that's often overlooked. In one of my latest AI projects, I was forced to use a Linux container on Proxmox for the very first time, and that really made me think about if I should use it a little more often in the future. Because LXC is a fantastic technology on Linux. It's great when you need a small environment that behaves just like a virtual machine to test or deploy applications, but without the overhead of a full-blown operating system. These containers are incredibly efficient and fast, but still provide a robust isolation layer. Especially on Proxmox, it's super easy to manage them. And another cool thing I just discovered recently, there are even ways to simplify the application deployment in LXC with community scripts or automate it in infrastructure as code tools like Terraform. Trust me guys, even if you are a huge fan of Docker or virtual machines, the capabilities of LXC on Proxmox might surprise you, so let's check it out together. Before we do that though, I quickly like to show you how you can easily manage all of your tech and home lab projects, because if you're juggling around different tasks and projects like me, you can lose track pretty fast. That's why you should use Monday.com, the intuitive all-in-one work platform where you can collaborate efficiently with a team, manage complex projects, and even automate repetitive tasks. Monday.com is super simple and intuitive to use. You can easily create to-do lists for the next actions that you're planning in your projects, create custom fields with additional nodes, manage priorities, or plan timelines. As you might know guys, I also absolutely love Kanban boards because that gives you the perfect overview of all the stuff that's going on. But you can also do some pretty cool advanced stuff like connecting different boards and adding dependencies between the tasks. For example, if one of your projects is to deploy a new application, but that requires the installation of a new server or adding certain DNS records first, for these type of workflows, Monday.com is just perfect. And you can even create stunning dashboards, reportings, documentation pages. It's super cool. To get started, just check out Monday.com by using the link in the description box down below and start streamlining your work like never before. Alright guys, so now let's take a look at LXC. Before we jump straight into some examples on Proxmox, let me first of all give you a little background about LXC, how it works and how it competes to other virtualization technologies you might be familiar with. So LXC simply stands for Linux Containers and was released in 2008. So it's already been around for quite some time. And at its core, LXC uses Linux kernel features like namespaces and C groups to achieve something that we call operating system level virtualization, and that allows you to run applications on the same Linux kernel as the host, but in their own isolated process space. So that's a pretty big deal compared to virtual machines, because virtual machines have their own kernel, their own drivers, therefore provide a stronger isolation layer than LXC, but that also means that virtual machines are much heavier and require more resources. By the way, containerization might be a concept you're already familiar with in case you watch many of my other videos, because there I mostly use Docker. And Docker is also a similar technology like LXC. In the early days of Docker, it even used LXC under the hood. But nowadays, Docker and LXC diverged significantly since Docker built its own containerization engine and stopped using LXC. And Docker also focuses a lot more on virtualizing applications, application packaging, and so on. And honestly, I have to say it, Docker even got a lot more attention in the recent years than LXC. But still, LXC, in my opinion, is a viable alternative to Docker, especially on Proxmox, because Proxmox allows you to easily create and manage LXCs directly in the web UI or even through automation. And it's really great in these situations where you just want to run some workloads in an isolated environment on Proxmox, but you don't want or need a full-blown virtual machine with its own operating system. In these use cases, it's often better to just use an LXC. But even though technically it isn't, LXC still feels like a virtual machine. So for example, instead of Docker, you can easily connect from your local machine to your LXC over SSH, log into the shell, install applications, even update the packages, whatever you want to do with it, just like in a virtual machine. You can, by the way, even run Docker containers in an LXC as well, if you want. And so it's, in my opinion, a super interesting technology that you definitely should try out if you haven't done it already. But of course, you don't have to do it alone, so let's do it together on my Proxmox instance. It's super simple to create LXCs on Proxmox. You first of all have to download a container template in Proxmox. These are the container images simply packed in tarball archives and contain everything that a container needs to run. You just go to your Proxmox node where you want to start the LXC, then select the local storage or any other storage where you have enabled CT templates. Then go to the templates and then go to download from URL if you have any custom location, or you can even use the Proxmox maintained images. Because Proxmox provides a variety of basic templates for the most common Linux distributions. You can find things like Ubuntu in here, OpenSUSE, Debian, but you can also download turnkey Linux container images. By the way, Turnkey is a project that creates pre-built, ready-to-use virtual appliance images. Essentially, they just take a Linux distribution, typically Debian or Ubuntu, then pre-install and configure popular software packages so you don't have to do it yourself. And this way you can easily deploy and install applications like GitLab or Postgres, Nginx, Drupal, Jenkins. So just go through that list, you'll find some really valuable stuff in here. But we are not using Turnkey today. I haven't really looked into this, to be honest. I will later show you another community project that I personally prefer using. Once you have downloaded your desired container templates on Proxmox, you can then start creating a new Linux container. So just simply go to create CT, which is right next to create VM. And then it's opening the familiar Proxmox menu, just like you would create a virtual machine. So select the node where you want to create this container on, give it a unique identifier. In my case, I'm just using this ID. I think that's fine. You also need to give it a host name, for example, LXC test 1. Then you also can decide if you want to run this as an unprivileged container. So I probably have to explain this. Historically, LXCs ran with nearly full root privileges on the host operating system. So this meant they had access to a wide range of host resources and kernel features. And this, of course, presented a significant security risk. Yeah, if a container is compromised, the attacker could potentially gain control of the entire host. That's why LXCs started running as unprivileged containers by default, isolating the containers as much as you can from the host kernel, limiting the potential damage in case of a compromise. And nesting is also another flag that is used in unprivileged containers. That basically mounts the /proc and /sys directories inside the container. So you can decide if you want to enable this or not. Maybe some applications might need access to these directories for managing processes or querying kernel options. Yeah. And even some workloads might require privileged containers, so then you have to disable it. But I would strongly recommend using unprivileged containers. Then you also need to give it a strong password that you can later use to log into the shell. And you can even upload an SSH public key. I probably do that because then I can demonstrate how that's working. Then you just select the template that you've downloaded. In my case, let's spin up an Ubuntu container. I think that's the best. Then you can create a new storage disk for the root file system inside the container. Give it any size that you want and a storage location. You can even decide how many CPU cores the container should consume and how much memory it should use. And of course, you can also select the network interface, enable or disable firewall, and if you want to use DHCP or a static IP address. And also select the DNS domain. In my case, I just use my local domain and my main DNS server in my home lab. I think that's fine. And then confirm. This is super fast. It's already completed in 2 seconds or so. By the way, when you go to the settings of the container, you can even do some other cool things like PCI pass-through, for example. Now that though works a bit different than in a VM. That's just because the technology is different. A virtual machine has a separate kernel with its own drivers, while a Linux container shares the kernel and the same drivers with a host. So instead of selecting a specific device, you have to enter a device path, so /dev/xyz. I needed to do that once in my AI video where I needed to pass through the graphics card of my Proxmox host into the container so it could be used by the local LLM. So if you want to have an example for that, then check out my video where I've installed Olama in an LXC. I'll link it to you in the description. But yeah, for this example, we don't need to do that. So let's start the container and go to the console. So let's log in with the root user and the password that I've already created. Here we are. By the way, of course, I can also open a shell. I just need to find out the IP address it has, the 18 at the end, root at the IP address. Yes, my public key should be already uploaded, and here we are. So you can see this is also working. You can update the app packages, install new packages. Don't treat this like a Docker container that always gets recreated when you update it to a new version. Think of it more like a virtual machine. So yeah, that's basically everything you need to know to get started with Linux containers. As I said, it's super simple, and you can now do whatever you want with it. Start installing Linux applications. You can even install the Docker engine and run containers on it if you want, yeah. But I want to share with you a super cool community project that I just recently discovered. And that is even making things a lot easier for you. And this is called the Proxmox VE helper scripts. So this is a collection of over 300 plus scripts that help you to manage your Proxmox environment, including LXC deployment scripts for all sorts of applications and workloads. Yeah, you can find databases in here, InfluxDB, MariaDB, MinIO, MySQL, Redis, Postgres, dashboards and front end, some typical home lab dashboards, yeah, or monitoring and analytics, things like CheckMK, I've recently done a video about that, or Grafana, Graylog, Prometheus. But you also find other stuff in here, like media and streaming services. I'm honestly not so into this whole stuff, to be honest. But yeah, I'm sure many self-hosting people will like this a lot. I think this collection is absolutely amazing. Just to demonstrate how easy it is to deploy a simple LXC using the Proxmox helper scripts, let me do something simple. For example, go to containers.docker, because I told you you can even run Docker in an LXC. Let's try to do this. So you just select your template or your script that you want to deploy, and then there is a one-line command that you just need to copy, so this one here, and then you just need to execute this in your Proxmox shell. By the way, make sure to use the shell from the Proxmox web interface. So select your node and go to shell and use this here. Don't connect over SSH, this won't work. And also, while the script is running, you should not leave the window and go into a different menu or so, because then the previous session might be lost. By the way, a cool tip that I can give you before executing the helper scripts, just execute the tmux session, because if you lose the window, you can always go back to the open session. Let's run this script here, for example. This will then start a new settings window where you can select default settings and so on. And if I would leave this window now, return back, it opens a new shell. But if you open the tmux command and then press Ctrl B and press S for session list, you can always revert back to the old one, and we are back. Okay, so let me just run through this. By the way, I'm not using the default settings because this assumes I'm using the VM Bridge 0 interface, which I'm not in my environment. So therefore, I have to customize a few things here and there. It takes a bit longer, but yeah, it goes through all the important settings. So first of all, choose the unprivileged container, set the root password so that we need to log in over SSH. Set the container ID, so I just gonna increase the number here. Set the host name, LXC test 2, I think that's fine. Disk size, let's give it 8 GB. Let's raise it a little. Allocate 2 CPUs, I think that's okay. 2 gigs of RAM. And now the important part comes. I need to select the other bridge, and yeah, DHCP is also fine. So yeah, just go through this. I think I don't have to explain all settings. Well, that might be interesting, the apt cacher IP. So this is another small container that you can run on Proxmox, and this helps you caching apt packages so that you don't have to download apt package updates for all containers. Instead, you're downloading this on one container that shares it with all others. I don't know, that might be for people that live in the past decade where fast internet connections aren't a thing, or maybe you are located in Germany, you don't have a fast internet, but I'll just leave it blank. MTU size, of course, we don't want to mess around with that. Don't do that, right? Set up a search domain. Oh yeah, okay, so that might be home.ccrave.de. and a DNS server IP. All right, so I think that's okay. So yeah, a lot of questions here and there, but yeah, I've chosen the advanced settings, so it probably was my fault. But here you can see what the script is doing in the background. So now it's setting up everything. It first starts with a basic container template and then starts installing all the other applications and things that are defined in the script, depending on what script or application you want to deploy. All right, so now it asks us if we want to install the Docker Compose plugin. Of course, we need that, so that's important. And if we would like to add the Portainer UI, well, yeah, why not? Let's do that. So that obviously takes a little more time. But you see, this really guides you through all the important processes. And yeah, so Docker setup has been successfully initialized. Let's also check if we can open this container over SSH. So here, I'm glad they already showed the IP address. So let's try to open this using the password that we have defined. Oh yeah, there it is. They even customized the login screen a little, so I really like this. I think at some point I might do a separate video on the Proxmox helper scripts, because LXC scripts are just one type of script they provide. There's a lot more good stuff in here, like virtual machine automation scripts or add-ons for Proxmox, like the Proxmox backup server. But yeah, I just need a little time for researching this. Of course, let's check if we can run a simple hello world containers. Here you can see we already got Docker on this LXC. Super cool. But of course, you can also use other automation tools. Yeah, for example, one thing that I want to show you is the Terraform provider for Proxmox. This is called Telmate, and you will find it in the Terraform registry. In the past, I've made 1 or 2 videos about it to explain how to automate the creation, managing, and provisioning of virtual machines. It also has some functions for managing LXCs as well. So let's go to my project. So here, for example, you can see that is how I'm managing my production LXC. And we can basically just use this template here to create a new container. So let's try to do this. I just need to change a few things here. For example, this production, I of course want to change to test free. And here the operating system template. So this of course has to match with the templates that you have downloaded here. If you don't want a static IP, just write DHCP in there. By the way, you will find all the details in the documentation on the Terraform provider page. So it's all well documented in here. Since it is a community project, it might have some issues and bugs here and there. So there's still a lot of work to make this really solid, but at least for me, it has been working well so far. So now that we have defined our resource template in Terraform, we can now apply the changes. So first of all, I will make a plan first to see what the tool will do when I apply the changes. So here you can see there's one new resource that it want to add. So this is my new LXC test free container. So let's just apply this. Yes. And now it's creating the new container. Unfortunately, I haven't found a way to set a specific ID, so it's using the default ID 100. But yeah, so here is our container. Let's see if we can connect to this. Yes, and yeah, so here we are. Alright guys, so that's basically how you use LXCs on Proxmox. Of course, that raises a question that I also ask myself, and that is, should I stop using Docker and instead use LXCs for my application deployments? Not really. I mean, I still want to use LXCs more often, especially for smaller applications or tests, or things that need to run independently of my other virtual machines. Like I could think about running my DNS server or maybe Home Assistant or the Proxmox backup server in an LXC. The cool thing about LXC is it certainly reduces the overhead of managing multiple systems, yeah? But of course, Docker and virtual machines also have their unique advantages. Like sometimes you want a stronger isolation by running a completely different operating system for your application, then use a virtual machine. Or if you like the simpler application deployment and update procedure that Docker images provide, then can use Docker containers. It's always the same, yeah? It isn't this one and only technology that is perfect for every situation. And maybe I will include LXCs and native Linux installation a little more in my future tutorials, but still, I think Docker remains the main technology and platform that I want to use for deploying my applications. Anyway, I still hope this gave you some interesting ideas on LXCs and how to use them on Proxmox. Please let me know in the comments what's your favorite virtualization technology and how you're running applications in a home lab. And as always, thank you so much for watching. A big thanks goes out to all the supporters and members of my channel. You guys are really amazing, and I'm going to catch you in the next video. Take care. Bye bye.